In this lecture, we want to learn about solving quadratic equations by this method of square root technique. So we have quadratic equations that are given in vertex form, and we want to know what is an efficient, fast, quick, nice method of solving these quadratic equations. So this is the first example, x plus 3 all squared minus 25 equals 0. It is a quadratic equation. The way we solve these is by isolating the expression that is quadratic, the binomial that is squared, isolated on one side of the equation. So I'm going to transpose negative 25 to the other side. It becomes positive 25. And then I have a perfect square on the left-hand side. Now, this is the step where we have to take the square root of both sides of the equation. So I'm taking the square root of the left side, and I'm taking the square root of the right side, okay? So square root of left side and square root of the right side. Now, when you're taking the square root of both sides of an equation, there's an important thing you should not forget, and that is placing the plus minus sign on one side of the equation. So whenever you're taking the square root of both sides of an equation, you should remember to put this plus minus because there's always two roots. If you think about it, if you have like x squared equals, let's say 49, okay, if you take the square root of both sides, and if you just say square root of x squared equals square root of 49, and you say x equals 7, you will end up with only one solution. Whereas in reality, there are two numbers that satisfy the equation. One of them is what you found, but the other one is negative 7, which you missed. Why did you miss the other root of this quadratic equation? Because you forgot to put the plus minus sign. But when you put the plus minus sign, you end up with plus or minus 7. That means there's two solutions. One is positive 7, one is negative 7. And both of these roots satisfy the equation, okay? So remember about the plus minus sign. I cannot emphasize more on this. So having that in mind, we have a plus minus on the right side, which gives me plus minus 5. And the square root of something squared will be that something itself. So we have x plus 3 equals plus minus 5. And now you're scratching your head. You're saying, okay, so which one should I take? Plus 5 or minus 5? Well, the answer is both. We take both of them. That means that we're going to break down the equation into two equations. Once we're going to count the positive 5 on the right side, and once we're going to count the negative 5 on the right side. So we end up with two simple linear equations. Now, if you solve the first one, you get 5 minus 3, which is, of course, 2. And then if you take the other one, you end up with negative 3 minus 5, which is x equals negative 8. So this means that the quadratic equation given to us at the top has two solutions. One is x equals 2, one is x equals negative 8. If you plug these in the original equation, it will satisfy the equation, and left side will equal to right side. You can try checking it by yourselves. So don't forget about the plus minus sign when you're taking the square root of both sides. Another example here, this one has a coefficient of 4 in front of x minus 1 all squared. So this time, I'm going to do the same thing, but perhaps one extra step in the middle. So I get 4 times x minus 1 squared, isolated on the left-hand side. The other side is 36. Now, this is the extra step I was talking about. I will divide both sides by 4 here. So I'm dividing left side by 4, right side by 4, and now I have a binomial isolated on left-hand side, and this binomial is squared. 36 over 4 obviously is 9, and now it's the moment that we have to take the square root of both sides. So I take the square root of left side, and I take the square root of right side, and I don't forget about the plus minus sign, which my teacher made a big deal out of it. So we get x minus 1 squared, and that is a 9. So that means that square root of 9 is 3. So x minus 1 equals plus or minus 3. Again, we end up with one equation, but we have a plus 3 on the right side, and we have a minus 3 on the right side. So that means that we have to split this problem up into two problems. Once we have to solve it with positive 3, and once we have to solve it with negative 3, which will give us the final answers of x equals 4 and x equals negative 2 finally. So this quadratic equation has two roots. One is 4, one is negative 2. And we solved it by using the square root method. There's another one over there. An interesting question. You will see why interesting shortly. This time, when I'm isolating x plus 5 on the left-hand side, and I transpose 49 to the other side, I end up with negative 49. So, like every other time, I try to take the square root of both sides, and so I write plus minus. I take the square root of the left side, okay, and here I have to take the square root of negative 49. So I use my calculator, I punch in square root of negative 49, I see the error message on the display of the calculator, and I'm scratching my head, I'm saying, what is going on here? Well, did I make any mistake or not? Well, you didn't make a mistake, actually, because the square root of negative numbers is undefined. Nobody can take the square root of a negative number because you cannot find a number, even if negative or positive number, it doesn't matter, that when you square that number, you end up with a negative answer. It is impossible, because negative times negative is always positive. So that's why you cannot take the square root of negative 49. So you're going to say, okay, so if you can't do that, if the calculator can't even calculate that square root of negative 49, what are we going to say about this quadratic equation? Are we going to say, oh, the answer is like what? Well, there is no answer. You are going to say no real solution. So this quadratic equation does not have any real solution, and that's why I said it's kind of interesting problem, because you don't have any real solutions. You don't have to do anything, basically. You don't have to solve the equation. It's not your fault that the quadratic equation didn't have any roots. The other two, they did have roots, actually. The roots, we found them, but this one doesn't have any real roots. So all you write on your paper is no real solution. But you got to show the work a little bit, of course, and because the reason is because square root of negative 49 cannot be, of course, calculated. Okay, so I hope you learned this method of square root method. It's a nice, quick, short method of solving quadratic equations. It becomes very handy when the equation is given in the form of vertex form. Okay, we will learn about other techniques in the next lectures. Thank you very much.